Hello students, welcome back to your online sessions, and as you all know, in the previous 5 videos we have covered a chapter called probability. That was chapter number 15 of yours. Now we are going to start chapter number 1 of your syllabus, and the name of the chapter is real number. So let us start the chapter real number. Now what is the meaning of real number? That is not new word for you. You have already studied these number in the 10th, 9th standard and 8th standard. So real number basically comprises of rational number, and irrational number. Right? Rational number include integers. Integers include whole number, and whole number includes natural number. Right? Natural number. Now all these number, you know that rational number means any number which can be written in the format of p by q. Q should not be equal to 0. Irrational number means which cannot be written in the form of p by q. Integers, all those number which is comprising of a negative number, 0 and positive number, but you will not have any fractional value. Whole number, 0 and all positive number, 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. That is whole number. And natural number comprises of 1, 2, 3, 4, 5 and so on. So all natural number are whole number. All whole number are integer, or integer are rational number, right? And all rational numbers are real number. Irrational number is having separate part, and this irrational number is also included in the real number. So this is the basic meaning of real number. Now in this chapter, in the very first chapter, that is real number, what we are going to learn? We are going to learn something about Euclid algorithm. Now what is Euclid algorithm or Euclid division lemma? That is the first topic that we are going to study. Okay, so let us start with the very first topic, Euclid division lemma. Before going towards Euclid division lemma, what is lemma? What is lemma? That is quite new word for you. You did not hear this word in the previous standard lemma. Lemma means already a proven statement. Which is used to prove some other statement. For example, if I ask you 3, 4, 5. If I ask you prove this statement for a right angle triangle, so you directly use AB square. If I this AB, A, B and C is there, so you use AB square plus BC square is equal to AC square. That is your Pythagoras theorem. But you are not proving this theorem. You are already using it. You are already using it to prove this statement, right? So lemma means any statement, which is already proved. And that statement, whatever we got as an answer of that proof, that we are taking that answer of the proof that as a result to prove some another statement. So lemma means the proven statement which is used to prove some another statement, right? So Euclid division lemma. Now Euclid division lemma, what it tells you, that if A and B are any integer such that A is equal to BQ plus R, where R is either 0 or more than that and less than B. This is the statement of Euclid division lemma. Now it is quite difficult. Let us see by example. Now you know that in a division, whatever there inside the division, we are taking it as a dividend. So let me take my dividend as A. Now if I divide this dividend by B, I am going to get some quotient Q. And I am going to get some remainder as R. Right? A is my dividend. If I am going to divide this A by a B integer, right? I am going to get some quotient. I am going to get some remainder. So how I can represent this this dividend? So this dividend can be written as A is equal to divisor into quotient plus remainder. A is equal to BQ plus R. That is your divisor into quotient plus remainder. For example, if 7 is there, you are dividing by 2. So 2 3s are 6 and 1. Right? 1 will be a remainder. So how this 7 can be represented? 7 can be represented as 2 into 3 plus 1. Yes or no? 2 into 3 plus 1. That is dividend is equal to divisor into quotient plus remainder. So A is equal to BQ plus R. Now this R, that is remainder, It can be either 0, it will not be negative because we are taking integers. We are not going to get here negative. So this remainder is either 0 or more than that, but it should be always less than b. B means your divisor. Suppose your remainder is 3. So you cannot call it as a remainder 3 because further division is also possible. You can multiply as 2 ones are 2. So when you are stopping the division, when the remainder is smaller than this divisor. So this remainder should be smaller than this divisor. So R can be 0 or more than any number, but it is always going to be less than your divisor, that is your B. So that is already proven statement, and this thing A is equal to BQ plus R, Euclid has used to prove many things, and that's why it is called as Euclid division lemma. A is equal to BQ plus R, where everything is in integer. A, B, Q and R all are integers. R is having a specific name, that is remainder, and Q is having specific name as a quotient. A is equal to BQ plus R. This statement is called as Euclid division lemma. That is the first topic. Then you might have, if you see your textbook, you'll come across a word algorithm. What is the meaning of algorithm? If I'll ask you, what is the meaning of algorithm? So algorithm is nothing but, suppose if I'm telling you just start your computer. So what will you do? You switch on the main switch. You will on the main switch. Then you will on your CPU, and then you put a password, and then your PC's front page, that is home page, will open. So to open the home page of your PC, you have followed a step-by-step something. You followed a step. First you have switch on the main switch, then you on the CPU, then you kept the password, and then your home page is got open. So algorithm is same thing. Algorithm means to solve any problem, we have to follow certain step. Step number 1, okay, done. Step number 2, done. You cannot move to step number 3 without doing the step number 1. So to solve any problem, we are having a step-by-step solution, and that step-by-step solution is called as algorithm. So this is also Euclid division lemma. In some book it is also called as Euclid division algorithm. So I hope this topic is clear. So whenever I am using Euclid division lemma, I am going to use A is equal to BQ plus R, where R should be either 0 or more than that, but less than B. Now what is the use of this? So Euclid, what he has done, in order to prove any number as an irrational number, like suppose I have to prove root 2 as an irrational number, I have to use this Euclid division lemma. Suppose I have to find HCF using Euclid division lemma, so I have to use this particular lemma which is given by Euclid. So our very first exercise, that is exercise number 1.1, it starts with find the HCF of a particular number using Euclid division lemma. So let us start our exercise number 1.1. Okay, students, so very first exercise, that is exercise number 1.1. What is the first question? Use Euclid's division to find HCF. Now before moving towards this term, HCF, then the second name of HCF is also called as GCD, right? So the name of HCF is highest common factor, and GCD means greatest common divisor. Both are same. This thing you have learned in the lower standard, that is I think in the standard 3 or 4, to find out HCF of two number. So how you can find out HCF of two number in general? Like suppose I have given you 15, and suppose I have given you number 3, 15 and 3. Two different numbers I have given you, and I am asking you to find out HCF generally. So you have to do the prime factorization of both the number. 15 can be written as 3 into 5, and 3 can be written as 3 only. It is already a prime number. So whatever common is there in both number, whatever common is there, like 3 is common, so HCF of 15 and 3 is going to be 3. HCF of 15 and 3 is going to be 3. Right? That is the basic methodology that you have studied in the standard 3 or 4. But here the question is use Euclid's division to find out HCF. So I have to find HCF only. But to find out HCF, I have to use Euclid's division. So let's follow Euclid division. So Euclid what? You have to use A is equal to BQ plus R. A is equal to BQ plus R. And your R should be more than 0 but less than B. That is what you reserve. So you have to use one number as a quotient, one number as dividend, and another number as divisor. So whichever the number is bigger, that is going to be your dividend, and whichever number is smaller, that is going to be your divisor. Means you can do your rough work here, and you have to do like this. 225 is a bigger number, so it will be a dividend, and 135 is a smaller number, and that's why it will be a divisor. So now you have to go closest to 225. While dividing 225 with 135, you have to go closest to 225. So let us do, if I do 135 twos are, I'll get 270, which is more than 225. So I have to go 135 ones are 135, that is 0, and 12, that will give 12 minus 3 will give you 9. Okay, you got this smaller, this number is smaller than this, remainder is smaller than your divisor, so this will be called as a remainder. Now that is your A is equal to BQ. BQ means 135 into 1 plus R is 90. See, 225 is equal to 135, that is B, and yes, and Q is 1 and plus R, right? Okay. Now when again you have to do the further division, when you have to do this kind of division till you are getting a 0 remainder. Until you are not getting 0 remainder, you have to follow the division process. Now first one was 225, that 225 was your dividend. Now what thing will going to be your dividend? So again, see, this number will be your dividend, and this remainder is going to be your divisor. Means further you have to divide this 90 by 135. 90 with 135 always. When you have to stop the process, whenever you are getting a 0 remainder, then you have to stop the process. Until and unless whatever your divisor is there, you have to divide the divisor by your remainder. So let's divide it. 92s are again going to be 180. So I'll get 91s are 90. So 5, and this will become 4. Right. So how this 135 can be written as? 135 can be written as B. B is a 90, quotient 1, and remainder is 45. Again here we did not get the 0 remainder. So again we have to divide this divisor with this remainder, that is 45 and 90. 45 twos are 90, and we are getting 0 remainder. So how this 90 can be written as now? 90 can be written as 45, that is the divisor, into quotient plus remainder. See, now we got the remainder as 0. Now what thing will be your GCD? We have solved this process. We got the 0 remainder. Whenever you are getting this 0 remainder, you have to stop your process. So as per Euclid division lemma, whatever your divisor is there, which is making your remainder 0, whatever your divisor is there, which is making your remainder 0, that is called as your GCD. When you got the 0 remainder, and at that time whatever divisor is there, that divisor will be called as your GCD as per Euclid. So here GCD of 135 and 225 is going to be 45. That is your answer. Okay, so first sum is clear. Okay students, so I hope you have understood the first question. Let us solve the second question now. The second question is nothing but 196 and 38220. So follow the same process. Whatever the bigger number is there, that is going to be your dividend. 38220, 196. Read it, close it. Read close towards 196. So 196 ones are 196, that is 6. That is your 17, that will become 8, and that will become 1, and again you have to take 1 carry. Now you have to go till closest to 9. Yeah, hide 1 digit here and hide 1 digit here. Read the table of 19 nearest to 186. So 19 9s are 171. So but I will say 9 will come. 9 6 are 54. 9 and 9 are 81. 81 plus 5 86, and 9 1s are 9. 9 plus 8 17. So 8, 9, 98, and that will be your, I think, 0. 1 0 will be carried. And 196, I think 5s are. So 5 6 are 30, 5 9s are 45, 45 plus 48, 5 and the 5 plus 4, 9. So you got 0. So directly you can write here 38220 is equal to 196 into 195 plus 0. See, directly you got the remainder 0 by dividing this number by 196. So which divisor is making this remainder 0? Which divisor? 196. So directly GCD of 196 comma 38220 is going to be 196, right? So choose two number, take the bigger number as a dividend, take the smaller number as a divisor, divide it, and if divide you have to go towards division till you are not getting the zero remainder. If you are not getting the zero remainder, whatever your divisor is there, that will become dividend. Whatever your remainder is there, that will become your divisor. So you have to follow this process until you are not getting as a zero remainder. And once you got the zero remainder, so whatever divisor is there which is making your remainder 0, that divisor is going to be your GCD as per Euclid division lemma. So we have learned how to find out GCD using Euclid division lemma. Third one is there, you do it by yourself. Okay, let us move forward.